All right, guys. So lesson 14 is all about determining outliers. And we want to investigate outliers and then how to identify them using a couple formulas. So that's what our Excel sheet is going to be used for here. So if you open up the lesson 1.14 Excel sheet, we have our warm-up here tab at the bottom. So if you don't see that, there's probably a couple dots here, and you can click those dots and it'll move it over so you can find your warm-up tab. So our warm-up is we want to just keep thinking about mean, standard deviation, how distributions are shown. So we have three statements here. The mean salary of 100 college graduates who majored in engineering was a certain amount, who majored in business was a certain amount, and who majored in social sciences. So all we're trying to do is match up which goes with which. So we're looking more at the mean here. So the mean salary of engineering was $63,750. If we look at this first histogram down here, there's no way that the mean could be over here around 60-some thousand, right? It's all bunched up around like 45. And if we go over to the last one, right? Again, we know the mean is going to be where most of the data is kind of clustered around. So if we look at the middle one here, we got most of our data right around that 60 to 65 with a lot of the data squished into that area. So we're going to go ahead and say this one would be engineering. The second one says that the mean for people who majored in business was 52,000. And also then we have social sciences was 45,000. So again, we're trying to look at which one of these would have the mean would be around 45 or 52, whereas about half the data on either side. So if we look here, right around 45, we got a couple big bars, another couple big bars, and then really low down here. So around 45, there's about half the data there on either side. So we'll say social sciences, and then this must mean that this has a mean of about 52. And if you look, the bar right around 52 is very big, and there's about half the data down on the left, and there's about-ish half the data there on the right. So we'll say this is business. Okay, so we're just trying to look at a few distributions. Now let's go to 14.1. We have a histogram and a box plot, and it shows the amount of money spent in thousands spent on each person in healthcare. It's something called per capita spending. But anyways, we have a histogram and we have a box plot. And there's one value as an outlier. And which one is it? And hopefully we can see that all of this data clustered over here. And then there's this one bar over here between 9 and 10. So we're going to say, yes, there is an outlier that is somewhere between 9 and 10. So why don't we just call it 9.5? So we're going to approximate at 9.5. We'll just split it down the middle. So it says one rule for deciding if a value is an outlier is if it is more than 1.5 times greater, 1.5 times the IQR greater than the Q3 value. So what we're going to do is we're going to determine whether or not statistically by a formula this is an outlier. So we look at our box plot. If we need Q1 and Q3, we're going to look at our box plot. If we zoom in on our box plot, we can see Q1, which is the left side of the box, falls at, I don't know, maybe like 2.1. And Q3, which is the right side of the box, falls at maybe, I don't know, 4.8. So let's call our Q1 2.1. Let's call our Q3 4.8. Now, remember that IQR is Q3 minus Q1. So we're going to, anytime we want to do a formula, we're going to do equals, select our Q3 cell minus Q1, hit enter. So the length of that box, our IQR is about 2.7. So now it says this rule talks about 1.5 times the IQR. So we're going to hit the equals, 1.5, shift 8, which gives us our time symbol, and we can select the IQR. Hit enter. Now, what we're saying is if you take that 1.5 times the IQR and you push it past Q3, that's going to kind of tell us whether or not an outlier exists beyond that. So if you take Q3 and you push out 1.5 times the IQR, anything beyond that is totally an outlier. When we say outlier, we mean it doesn't really fit the data. So we're going to do an equals. We're going to take Q3, select our Q3, plus the 1.5 times IQR, which we just calculated. Hit enter. 8.85. So, do we think that our value is an outlier? Yes, our value of 9.5 is an outlier because it extends beyond the 8.85 value that we calculated. We said that anything beyond the 8.85 will be considered an outlier. Okay, and there's reasoning behind that formula, but the whole 1.5 times IQR, but that we're just going to work with it as that formula there. Okay, let's go to 14.2. So we want to calculate all the following, and we also want to we're thinking about outliers. So we talked about this second one here, that upper outliers are Q3 plus 1.5 times the IQR. There's also lower outliers. That's anything that's below Q1. Q1 minus 1.5 times the IQR. So we're going to calculate all the following. Look, here's all of our data. All these numbers here. So the mean equals average. Double click. Drag all of our data. Close your parenthesis. Hit enter. Standard deviation equals standard dev. Use the first one. Double click. Drag our data. And the more we do this, the more we're going to get used to it. Hit enter. What's our min? Luckily, these are in order. So our min is the 1.0803. For Q1, that's something we need to calculate. So equals quartile, use the first one. Drag our data. Then remember, we need to tell it what quartile. So you need to hit comma, quartile 1, close your parenthesis, hit enter. Equals median, that's one that's easy to find. Drag your data, close it. Q3, we're going to use the same strategy, quartile, double click the first, drag our data. But now we want quartile 3, so we need to go comma 3. And then our maximum, if we look down here, 9.8923. So 9.8923. Okay. Now, it says the maximum value, I'm looking at number 2, the maximum value in this data set represents the United States and what they spend. Should it be considered an outlier? Well, we know that on the high end of outliers, on the high end, we need to determine, does that data value go beyond Q3 by adding 1.5 times the IQR? And again, that's just something that statistically someone came up with, that it makes sense. We're just going to use it. I don't know where the 1.5 came from. Who cares? I don't know. But we're going to use it. So if we need to figure out an outlier, we need the IQR, we need the 1.5 times the IQR, and we need to add that to Q3. So how do we find IQR? It's Q3 minus Q1. So we want to do a formula, equal sign. Go find our Q3 value. Click the cell, minus our Q1 value. Enter. 1.5 times that. So we're going to do equals 1.5 times. Click the IQR cell, enter. And now we need to take Q3 plus that 1.5 times IQR. So we're going to go equals, click our Q3 cell, plus, right, we're mimicking the formula that's right next to it. And we just found the 1.5 times IQR. Hit enter. 9.12165. So should that maximum value of 9.8923 be an outlier? Yes. The United States spending of 9.8923 is an outlier. because it falls beyond the value we calculated of 9.12165. It's as simple as that. It's higher, it goes beyond that, so we call it an outlier. Number 3 asks us to make a box plot for the data. So this is actually, we're going to keep it simple. It's pretty easy to do. If you want to make a chart out of your data, you drag your data, collect all your data, you go to Insert, Recommended Charts. You'll see a tab up here. It says All Charts. And you go down to Box and Whisker. And then you can click OK. And now you can move your chart right over here. So the box plot is just tipped vertically. We're usually used to seeing it horizontally, but it's just tipped vertically. Look at this dot up here. That's our dot that defines an outlier. Look, it says the value is 9.8923. So your box plot, right? You have your min down here, your Q1, your median goes through the middle, your Q3 is on top because our scale is getting bigger as we go. Our maximum's up here, and this is an outlier. So it actually doesn't even consider this to be part of the box plot because it's an outlier. So it's kind of just, just a way to see that. So now we're asked, although outliers should not be removed without considering their cause, let's see how the statistics change if we get rid of the outlier. So it's asking us to move our data and plop it over here. So I'm going to collect all of our data except the outlier. So do not include the United States. You can copy this. You can right click and copy. You can go over here to column J, which is right here, and you can do right click, paste. And we have all of our data. Okay. So now let's do our calculations again. Let's find the mean by doing equals average. Drag our data. And this is really just so we can compare. That's all we're doing is now we're going to go through these formulas again. Equals standard dev. Drag our data. Close it. The min we know is the same, so 1.0803. Q1 is equals quartile. Select the first one. Drag our data. We need to put a comma 1 because we're doing quartile 1. Median is an easy one. Equals median. Quartile 3 is the same thing. Equals quartile. Drag our data. Comma 3 because we're now doing quartile 3. And our maximum, our new maximum, look, it's not the 9.8 anymore. It's the 6.6475. Now, we can find our IQR by doing equals Q3 minus Q1. Boom. Right, here's our new data without the outliers, or the outlier in this case. So we're asked, how did the mean, standard deviation, median, IQR compare to the original? So let's first talk about the mean. Our original mean is 3.72. Our new mean is now 3.53. So without the outlier, our mean decreased because the outlier was a high number, and when we cut that out, our mean went down. We want to look at standard deviation. Our original standard deviation was 1.82. Now our new one is 1.50. So our mean decreased. Standard deviation also decreased because we took out a high value, and now the data is not as variable. It's not as spread out. We kind of cut it down, so it's a little less spread out. What about the median? The median before was 3.49, and now the median is 3.39. So the median decreased very slightly. It still did. And what about our IQR? Our original IQR right here was 2.79, and our new IQR was 2.67. So, and our IQR decreased. We can say this is because we took out a big data value. So naturally, everything is going to shrink a little bit. Some more than others, but naturally, everything's going to shrink. When you take out your outliers, most, if not all of your, excuse me, all of your metrics are going to decrease. Okay, let's go to 14.3. So once again, this is now we're talking about the number of property crimes for 50 California colleges. So let's do all of our calculations again. So for the mean equals average. Select our data. Right, now we're getting a little more used to this. Equals standard dev. Our data. The minimum looks like 15 because our data is in order. Quartile 1, go to quartile, drag our data, and remember, since we want quartile 1, we need to do comma 1. Median is the easy one. Drag our data. Q3 equals quartile. Drag our data. Comma 3. Our maximum, if we go down here, is 768. And we find our IQR by doing equals Q3 minus Q1. Okay, are there any outliers? So remember, we need to determine outliers, we take 1.5 times the IQR. So we're going to go equals 1.5 times, select the IQR. Okay, if I go back to this real quick, remember the lower boundary is you take Q1 and you subtract that value, and the upper boundary is if you take Q3 and you add that value. So, whoops, sorry about that. So, for the lower boundary, we're going to take equals. We're going to take Q1 and we're going to subtract the 1.5 times IQR. Hit enter. We get negative 271. For the upper boundary, we're going to take Q3. Sorry, we're going to go equals, take Q3, and we're going to add that 1.5 times IQR. 589. So are there any outliers? Well, certainly there's no negative numbers. So there are no outliers on the low end. But let's go down to our data. Remember, 589, 589, 589. Looks like we have the last three, 1, 2, and 3. 593, 699, and 768. There are 3 outliers on the high end. 593, 699, and 768. 593, 699, and 768. Now, remember what we're talking about. We're talking about property crimes for California colleges. Just simple things. Things like maybe spray painting stuff or broken glass or, a window breaks or just property crimes. So the question is now once we have all these outliers, why do we think they exist? And should they be included? Well, maybe they exist. Think about it. It's California. So these outliers might exist because there are some huge colleges in California. So if you have a big college like California State University, right, or UCLA or USC, those might be huge colleges. So they have tons of property and just little things tend to happen. So if most of the data is tracking small colleges, then maybe we shouldn't include big universities like UCLA or USC or Cal State. Maybe. Should they be included in the analysis of the data? It depends. So whether or not they should be included depends really on how much they affect all of our statistics, like mean, median, IQR, etc. If they really, really affect them like way too much, then we probably won't include them because they kind of skew our data. Okay? So the last thing here is the cool down. All I want you to do is think whether or not any of these could be outliers and tell me about it in question 1. In question 2, it says if after, like, people didn't want to include fish. So if the 3 becomes a 2 and the 21 becomes a 1, how would those changes affect the median, the mean, the standard deviation, and the IQR? Think about it. If you take away a big value that could be an outlier, how is that going to change all of your statistics? Okay. Sorry about the Zoom, guys, but yeah, we'll give the homework your best shot. We'll figure something out. But remember, a lot of the problems are from previous lessons. So you guys should be good with the homework. Due Tuesday. I'll see you guys then.